All right, so this question says we have 100 grams of water. It's at 100 degrees C, and it's mixed with 50 grams of an unknown liquid at 30 C. And the final temperature is 50 C, and we want to know what is the specific heat of the unknown. So we have the water. We know that the mass is 100 grams. The specific heat, we're going to round that off to 4. So I don't want to deal with decimals. I'm sure you don't either. Our T1, our initial temperature, is 100 degrees. And that's all we got so far. Unknown, the mass is 50 grams. T1 is 30 C, because we have 50 grams. We don't know C. And it starts off at 30. Then it tells us the final temperature is 50 degrees C. And so both of them have 50 C as T2, because that's the final temperature. And so we know that Q, our energy that we're absorbing, is equal to our mass times our C times our change in temperature. We also know that energy is conserved. So that means that energy gained is going to be equal to energy lost. And we have this negative sign so we don't end up with weird negative numbers. Does that make sense so far?
Yes.
Okay. So we haven't done any math yet. We just pulled out everything from the question. So if we have Q is equal to Q, then we can have MC delta T is equal to negative MC delta T. And so if we figure out who's gained and who's lost, if we look at the water, it goes from 100 C to 50 C. Is that gaining or losing temperature?
Gaining?
From 100 to 50?
Oh, I wasn't paying attention. Losing.
Losing. So all the water stuff goes with the lost. So we'll put equals 100 grams times 4 joules gram Celsius times our change in temperature. That's going to be T2 minus T1. So 50 minus 100. So that means all this stuff goes on the other side. Because if it's not losing, it's gaining. If we didn't know that, we look at 30 to 50, it's gaining temperature, so it's gaining energy. So 50 grams times C we don't know, times 50 minus 30. Yes. Wait. 100 to 50 is gaining energy. I think you're right the first time, Kayla. I'm sorry. So here's our Q gain. Q lost. We'll put the negative. Which one you assign is which isn't a big deal. It's just to account for the negative sign. So from here, we just do algebra. Are we okay so far?
Yeah.
Okay. So we plug this in. 100 times 4 times 50 minus 100. 20,000. Oh no, we were right the first time. I'm sorry, I'm confusing you with the negative signs. We'll do another one. plug all of this in. 50 times 20 is 1,000. Then just divide. So 1, 2, 3, 1, 2, 3. So 20 is equal to C. So our unknown is 20. I take it we want to do another one?
Yes.
Okay.
Sorry.
No, that's good. We're good. Let's see. Let's go back to here. All right, so if we look at this one, they want to know what is the mass of water if we had 200 joules of heat, the temperature increases from 12 to 20, and the specific heat is 4. We're going to round it off to 4. So mass, we don't know. If it's in heat, it tells you that this is the heat, that's your Q. It tells us that T1 is 12, and T2 is 20. We set our specific heat, we're going to round off to 4. Then we plug in our formula. We have Q, MC, delta T. Then we plug in the variables. So we have 200 for Q, mass we don't know, 4 for the C, and delta T we take T2 minus T1. So then we solve for M. So what is that? 4 times, actually I think I can pull up a calculator and that would be easier. Maybe. Now we have 200 divided by 4 times 20 minus 20. 32, and then 200 divided by 32, 6.25. So we had 6.25 grams to start with. Does that help, or you want to do one more?
That's good.
We're good?
Yeah.
Okay.
Miss,
Yeah.
how do you get power school on the computer?
Hmm?
How do you get power school on the computer?
You can just log on to PowerSchool and then type in all of your you type in